to all. Previous classes we have learned about measurement, measuring instrument, mass and weight. Today we are going to learn about the difference between mass and weight. Already we have learned what is the definition of mass. What is the definition of mass? Suppose we are purchasing 1 kilogram of rice. So only one rice is there? No. So more amount of rice is there. No. So the amount of quantity contained in it. That really definition of mass. What is the definition of mass? Amount of quantity contained in it. Now weight. Weight is a derived quantity. Already we have learned about the formula for weight. What is the formula for weight? W equal to mg. W weight, m mass, g acceleration due to gravity. So we are saying this weight is a derived quantity. Why we are saying derived quantity? We are using formula and derived. So weight is a derived quantity. So let us see what are the difference between mass and weight. See, first point, mass is a fundamental quantity. Weight is a derived quantity. This is the first point, mass is a fundamental quantity, weight is a derived quantity. That's point number 2. Mass is a scalar quantity. And weight is a vector quantity. Why we are saying scalar quantity? Only magnitude is there. But vector quantity, both magnitude and direction is there. So scalar quantity, only magnitude. Vector quantity, only magnitude and direction also there. Then third point is the definition of mass. What is the definition of mass? Mass is the amount of matter contained in it. Amount of matter contained in it. So the definition of mass is amount of matter contained in it is called mass. Now we can see the weight. The definition for weight, the force exerted by an object against the gravitational pull. Force exerted against gravitational pull. The force exerted by an object means the surface of a ball against the gravitational pull. The definition for weight. There is definition for mass. Then fourth point, what is the unit of mass? The unit of mass is kilogram. What is the unit of weight? The unit of weight is Newton. The unit of mass is kilogram and the unit of weight is Newton. Now, next, fifth point, the mass does not change from place to place. That remains same. Remain same. But weight changes from place to place. So why we are saying the weight changes from place to place? The acceleration of gravity Earth is 9.8. But suppose we are on the moon, the acceleration due to gravity of moon is 1.63. So just the value will change. Suppose the mass 10 kilogram. So W equal to mg formula 10 into 9.8. What is the value? 98 will get. Suppose if the moon, the mass 10 is 10 into 1.6. The value will change 6 times lesser than Earth. So the weight changes from place to place. Then sixth point, the mass can be measured by using beam balance. Last class we have learned about beam balance. So the mass can be measured by using beam balance. Weight can be measured by using spring balance. So these are the important question, difference between mass and weight. The first point, the mass is a fundamental quantity, weight is a derived quantity. The mass is a scalar quantity, only magnitude, but the weight is a vector quantity, both magnitude and direction. Then the definition for mass, amount of matter contained in it, the force exerted by an object against gravitational pull. The unit of mass is kilogram, the unit of weight is Newton. And the mass remains same, but weight changes from place to place. The mass can be measured by using beam balance. The weight can be measured by using spring balance. Then Roman letter 9, question number 4. The question, weight is given, W equal to 98 Newton, weight is given. G, question, they are not given the value of G. So we have to write the value of G, 9.8 meter 7 power minus 2. What you have to find means mass you have to find. So what's the formula for weight? W equal to mg. By using this formula we have to find mass. So m equal to weight divided by acceleration due to gravity. So m equal to, what's the value of weight? 98. So we have to write 98 divided by, what's the value of G? Already we have written here, what is given written. So that is 99.8. Then we have to divide here decimal point. So one decimal after only one number is there. So numerator and denominator you have to multiply with 10. So 10 divided by 10. The next 980 divided by 98. So what's the value? Just you cancel and you will get, what's the value? 10. What's the unit of mass? Kilogram is the unit of mass. So the m equal to 10 kilogram. So this Roman letter 9, question number 4. So you have to note it this Roman letter 9, question number 4 problem. So here what is given, first you have to write only weight alone given, G value not given, we have to write 9.8, mass you have to find out, then write the formula, then from this formula mass equal to weight divided by G, then substitute the value, you will get the answer 10 kilogram. Now we can mark the question, Roman letter 7, take a book students, Roman letter 7, question number 3, differentiate mass and weight. Page number 10, the table column, differentiate mass and weight. Mass is a fundamental quantity, weight is a derived quantity. It has magnitude alone, scalar quantity. It has magnitude and direction, vector quantity. It is the amount of matter contained in a body. It is a normal force exerted by the surface of an Fourth point remains the same everywhere, varies from place to place. Fifth point, it is measured using physical balance, it is measured using spring balance. Its unit is kilogram, its unit is Newton. Just to mark it. Then first lesson assignment, Roman letter 7, question number 1 and question number 3. Just you take a booklet, the last year booklet, take it and just you write this, study and write these 2 questions and get a signature from your parents. After school reopen, you should keep this assignment. Then chapter 2. Now we can see the chapter 2 motion. What is motion? See, suppose I am standing one place. Just I am moving from one place to another. So my body moves from one place to another. That's what motion. So motion is what? A body moves from one place to another is called motion. And rest. Rest, say I am standing the same position. So my body is at rest. So rest means my body does not change from one place to another. That is rest. So we have learned about motion and rest. So what is motion? A body moves from one place to another is called motion. What is rest? The body does not move from one place to another is called rest. Now you have clear about motion and rest. Then we can see the types of motion. So first one, linear motion. Second one, circular motion. Third one, oscillatory motion. Fourth one, random motion. See the types of motion: linear motion, circular motion, oscillatory motion and random motion. What are the types? Linear motion, circular motion, oscillatory motion, random motion. Now we can see the linear motion. First we can see about linear motion. Look at this picture. A body moves along a straight line is called linear motion. What is linear motion? A body moves along a straight line is called linear motion. Next one is circular motion. The motion along a circular path is called circular motion. Circular motion, a motion along a circular path is called circular motion. Next one, oscillatory motion. Look at the picture. The repetitive to and fro motions are called oscillatory motion. The repetitive to and fro motion is called oscillatory motion. The last one is random motion. Random motion, the body moves along randomly is called random motion. So far we have learned the four types of motion. What are they? Linear motion, circular motion, oscillatory motion and random motion. You have seen the picture. The linear motion, the body moves along a straight line. And the circular motion, a body moves along a circular path. Then oscillatory motion, the repetitive to and fro motion is called oscillatory motion. Random motion, the object moves randomly. This category does not fall this category. Which category? Linear, circular and oscillatory. This object moves along randomly. The next we can learn about the uniform motion. Uniform motion. So uniform motion, equal distance and equal intervals of time. What is uniform motion? Equal distance and equal intervals of time. Suppose within 10 minutes, this time distance. The car moves 1 kilometer. Or within 20 minutes, 2 kilometer. 30 minutes, 3 kilometer. 40 minutes, 4 kilometer. Now listen here. Here uniform means the time also uniform. 10. It's increasing 10 minutes. 10, 20, 30, 40. Distance also 1, 2, 3, 4. Like that it is increasing. So the uniform motion means the equal distance and equal intervals of time is called uniform motion. Then non-uniform motion. Non-uniform motion, unequal distance with equal intervals of time. Unequal distance with equal intervals of time. So uniform means equal distance with equal intervals of time. But non-uniform, unequal distance unequal but time same. So unequal distance with equal intervals of time is called non-uniform motion. So let's study uniform and non-uniform motion. What is uniform motion? Equal distance in equal intervals of time. Here unequal distance and unequal intervals of time. Look at this picture. Uniform motion and non-uniform motion. Uniform motion, a train moving with a high speed. The time also equal and the distance also equal. And second picture, look at the second picture, that is non-uniform motion. The waterfalls. that unequal distance but equal time. So the uniform motion means equal distance and equal intervals of time. Non-uniform motion, unequal distance and equal intervals of time. So in this lesson we have learned about motion, rest and types of motion. So what are the types of motion we have learned? Linear motion, circular motion, oscillatory motion, random motion, uniform motion and non-uniform motion. So clear it, students? Then next one, distance and displacement. So distance all of you know 5 kilometer distance. So 5 kilometer distance we have to move. Any way we can go, but there is no direction mentioned in distance. Distance, actual path, which way we have to go. Suppose from the school to Karungal we have to go. Different ways are there. No, any way we can go. So that's a distance. Sometimes 1 kilometer means sometimes 1.5 kilometer is there. So any way, any direction we can go for distance. That actual path, which path we like, that path we can move for distance. The unit of distance is meter is the unit of distance. So the distance is a scalar quantity. Scalar quantity. What is scalar quantity? Only magnitude is there. There is not mentioned direction, not mentioned. So the scalar quantity means only magnitude. So the distance, actual path, distance is the actual path. There is no direction, irrespective to the direction. So the unit of distance is meter, and the distance is a scalar quantity. The unit of meter or such, or unit of distance is meter. Now look at this displacement. Now we can see about displacement. See, suppose I want to go from this end to that end. I can go through this way also I can go. I can go from through this way also I can go. So through this way also. So which one is the shortest distance? That will be say as a displacement. So 100 meter running race. A different rack is there. No, each person's have different rack. So that rack only we have to move. So the 0 to 100. First one initial point is there and final points is there. The distance between the initial and final is as a displacement. So the displacement has certain direction. Direction mentioned in displacement. What is the unit of displacement? Meter is the unit of displacement. And the displacement is a vector quantity. Vector quantity. Distance is a scalar quantity we have learned. Only magnitude is there. But displacement is a vector quantity. So magnitude and direction is mentioned here. So what is the difference between distance and displacement? So the distance is the actual path irrespective to this direction. But the displacement, the shortest distance between 2 points, so you will say as the displacement. That is the direct path. Their direction is mentioned in this displacement. The unit of displacement is meter, and the displacement is a vector quantity. Vector quantity, both magnitude and direction is there. So let us learn about distance and displacement. Next is speed and velocity. Speed and velocity. Now look at the speed. The formula for speed. Speed equal to distance divided by time. What is the formula for speed? Distance divided by time. By using this formula, we can make to write the unit. So what is the unit of distance? Already we have learned. What is the unit of distance? Meter. So just you have write m. Then what is the unit of time? First lesson we have learned. What is the unit of time? Second. So here divided by second, denote the letter yes. So meter, this divided symbol, that per we have to say meter per second. So this yes, where it is in denominator. This we have to take as numerator. So we will get the unit meter second power minus 1. So what is the unit of speed? Meter s power minus second power minus meter second power minus 1 or ms power minus 1 is the unit of speed. Through this formula we have to find, suppose problem, speed given, time also given. You have to find the distance. How we will make this formula? distance equal to speed into time. Distance equal to speed into time. So speed also given, time also given. You have to find the distance. Then just multiply and you have right answer, and the unit, which unit you have to write? Distance unit. What is the unit of distance? Meter unit you have to write. So the speed formula, distance divided by time. The unit of speed is meter second power minus 1. Now we have to learn about the definition for speed. The rate of change of distance is called speed. What is speed? The rate of change of distance is called speed. So the definition for speed, the rate of change of distance is called speed. The unit of speed is meter second power minus 1. So the speed is a scalar quantity. Why we are saying scalar? Because distance. There is not mentioned direction. Only magnitude is there. Okay. So the speed is a scalar quantity. The formula for speed is distance divided by time. The unit of speed is meter second power minus 1. So this is all about the speed. Now we can see the velocity. See the formula for velocity. Velocity equal to displacement divided by time. So what's the formula for velocity? Displacement divided by time. So the definition for velocity, rate of change of displacement is called velocity. What is the formula for velocity? What is the definition for velocity? Rate of change of displacement is called velocity. Now say the rate of change of displacement is called velocity. By using this formula, we can write unit also. So what is the unit of displacement? Meter. What is the unit of time? Second. So we can write the unit meter second power minus 1. The same unit, speed also meter second power minus 1. Velocity also meter second power minus 1. Here we have learned speed is a scalar quantity, but velocity is a which quantity? Vector quantity. Vector quantity. Why we are saying vector quantity? Because the displacement, which one is important? Direction. Magnitude also there, direction also there in a displacement. So velocity is a vector quantity. Now what is the difference between the speed and velocity? The question asked means you have to answer. The speed is the rate of change of distance is called speed. What is speed? The rate of change of distance is called speed. The rate of change of displacement is called velocity. So first difference, the rate of change of distance is called speed. The rate of change of displacement is called velocity. The unit of speed is meter second power minus 1. The unit of velocity is meter second power minus 1. The speed is a scalar quantity and the velocity is a vector quantity. Here, suppose in this formula we have to find displacement. How will you find? So displacement equal to, just you have to multiply velocity into time. Velocity into time. So the displacement equal to velocity into time. What's the unit for displacement? Meter. Just multiply and write the unit for displacement. Okay. So we have learned about distance and displacement and speed and velocity. So next chapter is acceleration. We have learned about acceleration. Acceleration. The formula for acceleration is change in velocity divided by time. So what is the formula for acceleration? Change in velocity divided by time. The formula for acceleration, change in velocity divided by time. So the acceleration, rate of change of velocity is called acceleration. The definition for acceleration is rate of change of velocity is called acceleration. Then change in velocity. What are the velocities are there? Final velocity and initial velocity. So to change in velocity means final velocity and initial velocity. How we will find the final velocity? How will we find the initial velocity? See, suppose 100 meter running race. We are standing for running race. So that is the initial velocity. Then after completing 100 meter, we will stand another place. No? So that is the final velocity. Now, so in this change in velocity, we have to write final velocity minus initial velocity divided by time. So final velocity minus initial velocity divided by time. Change in velocity, here we have to write final velocity minus initial velocity divided by time, that is acceleration. What is the definition for acceleration? Rate of change of velocity is called acceleration. Rate of change of velocity is called acceleration. So here change in velocity, final velocity minus initial velocity divided by time. So the acceleration denote the letter A. What is the denote the letter? Acceleration denote the letter A. Final velocity denote the letter V minus initial velocity denote the letter U divided by time denote the letter T. So this is the formula for acceleration. What is the formula for acceleration? So formula for acceleration, change in velocity divided by time. From there, change in velocity, final velocity minus initial velocity divided by time. Final velocity denote the letter V, initial velocity denote the letter U, and time T. Acceleration denote the letter A. So A equal to V minus U by T. What is V minus U? Change in velocity. V minus U means what? Change in velocity. T means what? Time. A, acceleration. Okay. So let's learn about acceleration. What is the definition of acceleration? Change in velocity divided by time is called acceleration. And how will we find the unit? We can find the unit of acceleration. So velocity unit already we have learned. What is the unit of velocity? Meter second power minus 1. So here we can write meter second power minus 1 divided by time is the time unit second. Then this, if you take numerator, a meter second power minus 1, this also you will get to second power minus 1. This minus 1 and minus 1 minus 2. So meter second power minus 2. The unit of acceleration is meter second power minus 2. What is the unit of acceleration? Meter second power minus 2. What is the unit of velocity? Meter second power minus 2. This is everything fundamental. Speed, velocity and acceleration fundamental. Just you have to learn formula and unit how we can change this by using the according to the problem, how we can use this definition. This formula just you should know. So the unit of velocity is meter second power minus 2. How to find this acceleration? Now see the final, suppose 100 meter running race. Final velocity, what is the value? A equal to, what's the final velocity? 100 meter running race means that is 100 minus initial 0 divided by time. On time given or within 10 seconds, like that given. So 10. So how will you get 100 divided by 10? You will get the 0 and 0 cancel 10. What is the unit of acceleration? Meter second power minus 2. Like that you have to find out by using this formula. Okay. Now acceleration, change in velocity divided by time. That's the formula. Change in velocity we have to write final velocity minus initial velocity divided by time. Final velocity denote the letter V, initial velocity denote the letter U, and time denote the letter T. A denote the letter acceleration denote the letter A. So we have learned speed. What is the formula for speed? Distance divided by time. Formula for speed. What is the unit of speed? Meter second power minus 1. What is the formula for velocity? Displacement divided by time. This definition, how we should say the definition? Rate of change of displacement is called velocity. What is the unit of velocity? Meter second power minus 1. Then acceleration. What is the formula for acceleration? Change in velocity divided by time. What is the definition for acceleration? Rate of change of velocity is called acceleration. Then we have to get this formula A equal to V minus U by T. Suppose here final velocity is greater than initial velocity. See, final velocity is greater than initial. Here final velocity only greater. No. Final velocity is greater than initial velocity. That is positive acceleration. So positive acceleration, final velocity is greater than initial velocity. Then you should study the denote the letter alone. So final velocity denote the letter V. Initial velocity denote the letter U. So the final velocity is greater than initial velocity. We will get positive acceleration. Suppose the final velocity is less than initial velocity, you will get negative acceleration or negative acceleration or retardation or deceleration, you can say. Okay, so the final velocity is greater than initial velocity, you will get positive acceleration, and the final velocity is less than initial velocity, we will get negative acceleration. Another name for negative acceleration, deceleration or retardation. So these are about the acceleration, speed and velocity. So in this lesson we have learned motion lesson, we have learned the definition of motion and the rest types of motion we have learned, and speed, distance, displacement, speed, velocity and acceleration. All the definition, unit, everything fundamental you have to learn. Now take your book, just mark the answer. Room letter 6, first one, define velocity. The page number 16. The velocity heading is there or below that. Velocity is the rate of change of displacement. The definition for velocity. Velocity is the rate of change of displacement. Just mark it. Then the unit of velocity is meter second power minus 1. It is a vector quantity. Then you have to write the formula. Velocity equal to displacement divided by time. The next, distinguish distance and displacement. That page number 15. The distance settings, the actual length of the path travelled by moving a body irrespective of the direction is called distance. And here displacement defined as the change in position of a moving body in a particular direction. This first point. Second point, it is a scalar quantity. Distance is a scalar quantity. Here displacement is a vector quantity. Second point. Then third point, the unit of distance is meter second power minus 1. The displacement, the unit of displacement is, unit of distance is meter and the unit of displacement is meter. So these are the difference between the distance and displacement. The types of motion, detailed answer. Second one, explain the different types of motion. That page number 15. Types of motion is there, no? Linear motion, circular motion, oscillatory motion, random motion. That's mark it. 4 motion. 4 types of motion. Linear motion, motion along a straight line. Circular motion, motion along a circular path. Oscillatory motion, repetitive to and fro motion of an object at regular interval of time. Random motion, motion of the object which does not fall in any of the above categories. So just learn the types of motion and velocity, then the difference between distance and displacement. Those 3 questions just learn. Next class assignment also given. Just first lesson only 2 questions given. Just study and write and show your parents and get a signature and keep it one booklet. Last year old booklet, you know, just keep it. When the school reopens, you should show that assignment.